My name is Jim Finn. I work for International TechneGroup. We're a 30-year-old data exchange and interoperability company. If you've moved any CAD or CAE files from one CAD system to another, you've used our software. We've focused our information and our application down on the factory floor, and we would hope that this application lives right beside Excel, in where the machines are and where the people that keep the factory running. So our target is the frontline production workers that are on the factory. Could you please run the video?
MTConnect for Visio, January 2014. The purpose of MTConnect for Visio is to enable the investigation of unplanned shop floor issues by quickly collecting, analyzing, and viewing live shop floor data that is broadcast over the MTConnect channel. All that is needed to use this tool is a copy of Microsoft Visio, this software, and Microsoft Office drag and drop skills. To use MTConnect for Visio, open this software package from the Start button. Visio will start showing a blank drawing, a set of MTConnect stencils, and an MTConnect button ribbon. The MTConnect ribbon is accessed by clicking the MTConnect menu item. MTConnect for Visio is a modeling tool where shop floor data is captured from the MTConnect stream, then displayed live. Step 1 is to build the data capture model. This video clip shows what a data capture model looks like. The data capture model follows the MTConnect probe XML structure. The source of the MTConnect data is established with the device stencil at the top of the model, then controller stencils are added to navigate through the XML. At each device or controller stencil, the data items at that point in the XML can be captured. Step 2 is to model the data to be displayed. This video clip added to the data collection model a data display model. The next video clip will demonstrate building a data collection model, then displaying the data collected from the MTConnect stream in real time. The Mazak test site is used to demonstrate the live collection and display of shop floor data. Step 1 in using this modeler is to drag and drop a device stencil onto the drawing, then connect the device stencil to a shop floor machine that is broadcasting MTConnect data over the internet. In the process of connecting to a shop floor machine, you also select which data streams from the shop floor machine you want to monitor. You also select the scan rate to upload data. In this example, we are connecting to the Mazak MC1 machine provided by the Mazak test site and monitoring its Axis data. To monitor this Axis data, a component stencil is dragged and dropped onto the drawing. The device stencil is then connected to the component stencil using a connector stencil. The connector stencil is a pipe that feeds forward the data monitored by the device stencil to the component stencil. To activate the component stencil, we select which axis data to monitor. In this example, we will be monitoring the load values on the X, Y, and Z axis set. To access load values on a single axis, a second component stencil is dragged and dropped onto the drawing and connected to the first component stencil, which is monitoring all the axis data. For this example, we will select the X-axis to monitor by picking the X-axis data stream to be sent over the connector pipe, connecting the first and second component stencils. To view X-axis load values, a sample stencil is dragged and dropped onto the diagram, then connected to the sample port on the second component stencil with a connector stencil. The sample stencil goes live, showing real-time load values when the Run MTConnect diagram button is clicked on the MTConnect ribbon. There can be several ways to show data on a diagram. In this example, we also show the load data as a meter and as a set of statistical parameters about load values. Since this modeler is open-ended, more display stencils will be added in the future. All the drawing capabilities of Visio are retained. Here we are changing the connections from straight lines to right angles. Any other graphics or notes that are needed on the drawing can be drawn using normal Visio drawing tools and skills. Data can also be picked off at any level of the data collection model. Here we are connecting a rotary switch stencil to the device stencil to show the status of the machine tool's availability to broadcast MTConnect data. The next 4 video clips show examples of collecting and displaying shop floor MTConnect data using this modeler. This drawing calculates the statistics on the X, Y, and Z axis loads. The data calculated here could be used to provide actual parameter values for a shop floor simulator. This drawing monitors in real time the X, Y, and Z axis loads. This drawing monitors in real time the production status of the MC1 machine. This drawing captures the cut times on the 4 Mazak machine tools. The data can be used to validate the before and after improvements gained from an upgrade program in the machining area. This is an open-ended modeler that can be continuously expanded in functionality and ease of use by adding new stencils. Categories of stencils can be established to facilitate common shop floor investigation activity. A more full set of control panel widgets can be built from which virtual control panels can be constructed showing live views of equipment activity. Data processing widgets can be added that do common on-the-spot shop floor data calculations that would otherwise be difficult to quickly obtain from running machines.